All right, so let me start with the following example. Let's say I have the integral of 7 times sine cube of root x divided by root x. This is one of your homework problems on Weber sine. And how would you do this problem? Does it look like a function that I showed you last time? Not exactly, right? It's not just a power of sine and cosine, right? But looking at this, if you have done all the homework problems that I assigned from chapter 4 as a review, there was a problem like this, right? You had something of root x divided by root x in that. I think you had something like cosine root x over root x, something like that. And how did you solve that problem? You did a u substitution, u equals to? What did you take for u? Root x, right? So let's do that. So I'm going to take u to be root x, and then du would be what? Let me just write it this way. Well, root x is actually half, derivative is half, actually half minus 1, which is half actually negative half, which is the same as half 1 over actually half, and then I can write the derivative in this way. So, and notice that I could say then that 2 du is 1 over root x dx. So I'm going to make that substitution now. But before I do that, let me do the following. Let me take out the 7, and I have sine cubed of root x. And let me rewrite the integrand in this way. So I didn't do anything, I just rewrote it. Now I'm going to make the substitution. Clearly I'm going to get sine cube of u, and then 1 over root x multiplied with dx will be 2 times du, right? So 2 du I'm getting from this guy. And once I have this, now it's clear what to do, because I can rewrite this as 14. I am factoring out that 2. So if I take that 2 outside of the integral, I get a 7 times 2, which would be 14, and then I get sine cubed of u du. And now, what's my strategy if I have an odd power of sine? Very good. Save a factor of sine. So I'm going to write sine u du. And then the remaining power of sine is what? Sine squared of u. What should I do with the remaining power? I'm sorry? Remaining power? Go ahead. Yeah, so you have to convert it to cosine, right? So you use 1 minus cosine squared of u. In this case, I don't have any power on this, so that makes it simpler. So I get sine u du. And now I do another substitution, right? Are you guys keeping track of the substitutions? Okay. So what substitution I should be doing now? I should be replacing cosine by another variable. I don't want to use the same u, right? So let's use something else. W. So let's say w is cosine of u, and then dw would be negative sine of u du. So now I could say, well, this is 14 1 minus w squared, because cosine is that. And what is sine u du? Sine u du would be what? Negative dw, right? And the next step would be, I am going to get negative 14 outside, 1 minus w squared dw. And what's the integral of 1? W. And what's the integral of w squared? 1/3 w cubed. So that's what I get. Now finally, remember, those of you who have taken Calc 1 with me, I said, in Calc 2, when you go there, you might have to apply substitution a number of times, right? So in this case, we applied substitution twice. Now, w, I have to now, this is an indefinite integral, so I have to write my answer in terms of the original variable, right? So what's w? W is cosine u, so I get 1/3 cosine cubed of u. And then what is u? Yeah. So I get cosine of root x minus 1/3 cosine cubed of root x plus a c. Is everybody okay with that? You guys are okay with that? Any questions on that problem? Any questions at all? No? All right. Another problem, another example. This is also from your homework. Let's say I have the integral of 3 times cosine squared x times sine 2x dx. Notice that I have sine evaluated at 2x. I don't have sine squared of 2x. Okay? Sine squared of x. I don't have sine squared. I have sine 2x. And so what would you do in this case? What's the problem here? The problem here is that I don't have. If I had sine x, this is pretty easy to do. But I have sine 2x. So go ahead. Very good. You see, whenever you see a chance to apply a trig identity, you go ahead and apply that identity. Okay. So you see sine 2x, it should say, hey, double angle formula. The double angle formula will beg you to apply that. Okay, right? So you apply that, and see what happens. So this would be 3 cosine squared x 2 times sine x cosine x dx. And so I can rewrite this. 3 times 2 is a 6, so I'm going to take it outside. And notice that I have cosine cubed x times sine x dx, right? You agree with that? Now, so both powers of sine and cosine are odd, right? So which strategy would you follow? What is easy to do here? Is it easier to work with cosine or is it easier to work with sine? Yeah. I have a cosine x, cosine squared x. Yeah. Would you rather work with sine or cosine? So you want to save a factor of cosine? You want to save a factor of sine, and the remaining power is just 0, right? So that's why it's easy to work with sine. So here, I really don't have to do anything. All I have to do is take u to be cosine, right? Take u to be cosine x, and then du would be negative sine x dx, and I would be getting 6 times the integral of u cubed, and it's basically negative du, right? So let me, is it okay if I write the negative outside? So I get a negative du. I'll just write the negative outside. And what is that? Well, this is pretty easy, right? This is negative 6 1/4 times u to the 4 plus a c. And finally, what do I need to do? This would be negative 6/4 is what? Negative 3/2. U is cosine, right? So cosine to the 4x plus a c. Is everybody okay with that? Another example, but I'm not going to actually do this. I'll just tell you what you should be doing. So let's say I have the integral of sine to the 5x divided by cosine x. Suppose you have this integral. Okay, how would you do this? How would you evaluate this integral? What strategy should you follow?
Would you have a tangent x times sine x?
I didn't give you any strategy for tangent times sine. Yeah. Go ahead. U equals to cosine of. See, the problem is cosine is in the denominator, so you cannot save a factor of cosine as a cosine x. So in this case, what you have to do is you have to apply the. You have to save a factor of sine. Save a factor of sine, okay, and the remaining power of sine convert it to cosine, right? Then if you take u to be cosine, the necessary factor sine x is there. Am I making sense? Is everybody okay? In this case, you follow strategy number 1 that I told you yesterday, when the power of sine is odd, right? Save a factor of sine, convert the remaining power of sine into cosine, and then take u to be cosine. Everybody's all right? So I'm not going to do this problem. I just wanted to tell you that what to do. Okay? So I'm not going to write anything here. All right, is everybody clear on that? Let me do another from the homework. Let's say I have the integral of sine squared of theta d theta, and it goes from 0 to pi over 2. 0 to pi over 2. Okay, how would you do this problem? What should you do here? What should I do with sine squared? Even power, right? What should I do with it? Sine squared. What was strategy number 3 that we discussed last time? You rewrite sine squared as what? Half 1 minus cosine 2 theta here. Okay. And then this is the integral from 0 to pi over 2. Half minus half cosine 2 theta. What is the antiderivative of half? What's the antiderivative of half? Actually, let me do one more line, okay? Sorry. Let me rewrite this as integral from 0 to pi over 2 of half d theta minus half integral from 0 to pi over 2 of cosine 2 theta. What's the integral of half? The integral of half is half theta. And what's the integral of cosine 2 theta? Do you remember what we said last time? For cosine of some constant multiple of x, what was the antiderivative? It should be sine theta, sine of 2 theta, right? But multiplied by what? Multiplied by half. Very good. So this is half sine 2 theta. And now we just evaluate this. Now, just to simplify things, I'm going to write it as theta. I'm going to factor out the theta. Sorry, I factored out half. Yeah, in the next one, I am also going to factor out a half. Then I'm going to get 1/4. And I get sine of 2 theta from pi over 2 and 0. Is everybody okay? From the second brackets, I also factored out a half and combined with the half already outside there. So that's half times half is 1/4. I could do that. And what am I getting then? Half times pi over 2, right? Pi over 2 minus 0, right? Minus 1/4. What is, if I plug in pi over 2, what do I get? I get sine pi minus sine 0. Can someone tell me what do I get at the end? I'm getting pi over 4 here. And what am I getting from this, the brackets? 0. Sine pi is 0, sine 0 is 0. So pi over 4 is the answer. In your homework, the integrand is going to be cosine squared multiplied with some certain constants. Okay, but I did that with sine squared. But if you had cosine squared, what identity would you be applying? Instead of half 1 minus cosine 2 theta, it will be what? Half 1 plus. Okay, so keep that in mind. Any questions on that problem? Anybody? Yeah. Right here?
Yeah.
All right, so let's now look at the third type of integrals that we want to look at. So now I want to look at integrals like integral of tangent to the mx times secant to the nx dx. So we want to look at integrals like this. And again, I'm going to explain what to do depending on the exponents on tangent and secant. Here's by the way, the strategy that I'm laying out right now for tangent and secant powers, the same strategy applies if I have cotangent and cosecant powers. Okay. So here's an example. Let's say I have tangent I have tangent to the 6x, let's say, multiplied by secant to the 4x dx. Now, here, the case that I'm looking at is when the exponent on secant is even. So, the case I'm looking at when n is even. So, I'm looking at tangent to the m, secant to the n. And the case I'm looking at when the exponent on secant is even. So, what should we do in that case? Well, you are going to save a factor of secant. No, not a factor of secant. You're going to save a factor of secant squared. If I save a factor of secant squared, the remaining power of secant would be what? 2, because it's secant to the 4. And the remaining power needs to be converted. Secant squared, remember, secant squared of x is the same as 1 plus tangent squared of x. Secant squared of x is 1 plus tangent squared of x. And if I apply that identity, I get this. Now you can do a substitution, and the substitution that you want to do would be what? Yeah, you should be taking u to be tangent of x, and then du would be secant squared of x dx. Very good. And if I make the substitution now, I get u to the 6 times 1 plus u squared times du. So this would be u to the 6 plus u to the 8 du, which would be what? 1/7 u to the 7 plus 1/9 u to the 9 plus a c. And finally, what should I do? Yeah, you need to replace u by tangent. And I get this. Is everybody okay with that? You guys are okay with that? Is that making sense? Okay. Let me see. What if you have the case that I want to look at is when so whenever you see secant, the exponent on secant is even, you could follow exactly what we did in this example. Let's look at another example where you have let's say tangent cube x times secant cube of x. So here the case I am looking at is when m is odd. Remember, again, we are looking at integrals where the integrand has the form tangent to the m multiplied with secant to the n. So the case I'm looking at is when the exponent on tangent is odd. The exponent on tangent is odd. That's the one that we are looking at. So what should be our strategy here? Well, in this case, so in the previous case, I substituted tangent, right, by u. In this case, you need to substitute u equals to secant. But what's the derivative of secant? So I need to save a factor of secant tangent, okay? So let's do that. I'm going to save a factor of secant x tangent x dx. If I do that, what are the remaining powers? The remaining powers are tangent squared of x, secant squared of x. Okay? And what should I do? Remember, I'm going to substitute u equals to secant, which means the tangent needs to be written in terms of secant, which is what? Very good. Secant squared of x minus 1. So if you have the trig identities memorized very well, then it's going to be easy to do these problems. Okay, so remember, secant squared is 1 plus tangent squared, so tangent squared would be secant squared minus 1. And now you make a substitution, u equals to secant x, and then du would be secant x tangent x dx. All right, so let's make that substitution. I get u squared minus 1 times u squared times du. So what I get is u to the 4 minus u squared du, 1/5 u to the 5, 1/3 u cubed plus a c, and finally u is a secant, so I get secant to the 5 x minus 1/3 secant to the 3x plus a c. You guys are okay with that example? So what are the cases we have looked at? We looked at the case when the exponent on secant is even. We looked at the case when the exponent on tangent is odd. And we have a factor of secant as well, right? Now there are other cases. Unfortunately, I cannot give you, for other combinations of powers, I cannot tell you exactly what to do. It depends on the specific example. And usually for the other cases, you have to apply integration by parts that we haven't looked at, and we are going to look at. That's our next topic, integration by parts. That's another major integration technique, like U substitution. Okay? Any questions so far on these two problems? All right, so let me ask you a question. Just I'm not going to do the problem. So again, from a similar problem from your homework. Suppose that I have the integral of tangent squared x dx. What would you do? How would you find this integral? How would you find this integral? the strategies that we looked at above, it doesn't work. But what should you do? What should you try? Substitute u for what? No. Okay, what trig identity is begging you to apply that identity? 1 plus secant squared, right? Sorry, tangent squared is secant squared minus 1, right? And once you apply secant squared minus 1, do you know the integral of secant squared? Do you know the integral of secant squared? Tangent, you know the integral of 1. Right? You see my point? So if I convert tangent squared to secant squared minus 1, then I know exactly how to find the integral, because the integral of secant squared is known, integral of 1 is known, right? So that's what you need to do if you see that. Okay. Let me give you another example here. Let's say I have the integral of tangent square x plus tangent to the 4x dx. What should you be doing here? What should you do here? What did you do in this example?
Would you rewrite it kind of like the same way that for anticipations and coordinates you
Say it again. So you're saying write tangent to the 4?
No, you would write tangent squared x and secant squared x minus 1 and plus secant squared x minus 1.
Okay, but when you have secant squared x minus 1 to the power 4, you're going to end up with secant to the 4, right? Minus 2 secant squared plus 1. And you can apply the strategy when the power on secant is even in that case. Okay? I agree with that, but there is something easier than that. So that what you said is going to work out. It's just the computation is longer, but you could do something and make it simpler. Yeah. Yeah, pull out the tangent squared. So if you pull out the tangent squared of x, you get 1 plus tangent squared of x, right? You agree with that? And then what you get is tangent squared x times secant squared of x dx. And now you can apply the strategy in the case the exponent on secant is even, right? So basically that strategy is what? You take u to be tangent of x, and what is du? Secant squared of x dx, and that does it, right? Is everybody okay with that? So keep this example. These are from your web assigned homework, so you need to remember these hints when you do those problems. Okay. Any questions on this? Everybody is okay with that? Alright, for the remaining 10 minutes, so let me introduce you to integration by parts. We can't finish it today.